Solar energy, it's all about taking the sun's energy and converting it into electricity that we can use. But how does that process happen? And what is the technology and the products that make that happen? I'm here today at OSM Solar in Welland, Ontario, and we're looking at that process. And I'd like to introduce you to Al.
How are you?
Al is Vice President of OSM, and you make things happen.
It's my job to make sure we get a quality product out of our plant.
And really it is about taking sand, silicon, and turning it into something that generates electricity.
Exactly. We receive the raw materials here as in the form of an actual cell, and we take it from that process onto a finished product, and we can walk through it.
Well, and that's what we're going to look at here today. Well, Al, this looks like where it all begins.
You're correct, Tom. This is actually where it all starts. It starts here with the cell. The cell gets picked up by the stringer tabber, gets transferred into an inspection station. The cell then gets transferred to the flux station. The flux station applies flux on both sides, preparing it for the soldering of the ribbon. It's then transferred to the soldering station where all the ribbons are soldered together. It's soldered together with hot air. As they come through to the transfer station, they will then be picked up and inspected by the operator. The operator then will inspect each cell, front and back, and then transfer it to a tray which contains 10 strings, which basically makes one solar panel.
So when this process here is done, it's ready to then go together and have a number of these strings put together.
Correctly. Then that transfers to our layup station.
So Al, these are some of the strings that were made earlier?
Correct, Tom. That's from the last process we went through on the stringer tabber. So these strings are basically right now ready to make that rectangular shape that everybody knows as a solar panel.
Mm-hmm.
You'll see as the process moves forward here, these trays will be transferred to the next station where the machine will pick them up now, and what it's actually doing is you'll see it move to this next station where it's actually going to square them up. So it's telling the machine exactly where the parameters are, because we have a set parameter for our layup of the panel itself.
Okay.
It'll just then come across now to what's called the cutting machine. It cuts the ribbons to the proper length.
And now it's going to start assembling what we think of as a traditional panel.
Correct. It'll pick up 6 rows of 10 cells, 6 strings we call them, and that'll give you your traditional rectangular shape that everybody's accustomed to seeing as a solar panel. It's very precise because there's an exact measurement between each cell distance. So that's why it's very important that this machine lays everything up into precise measurements.
From an electrical point of view, we're really talking about creating something almost akin to a battery. Each one of these cells generating electricity being connected through this process in series.
Exactly, and that's probably the simplest explanation you can have for this. It's basically producing DC power.
So we're getting the accumulated effect of each cell generating a little bit of electricity, gang together in these strings, put together in the overall panel.
Exactly.
And then, of course, a number of these panels are going to be hooked together to generate the electricity.
Yeah, exactly. And then that DC power then will be converted through an inverter into your basically we call AC, or your household power.
What we can use in the house.
Exactly.
So it's almost done here. It's on the 5th string.
Correct. We have one last string coming up, and then when you see it, now it's starting to resemble an actual solar panel.
Mm-hmm. You know, we see these as these individual squares, but maybe just didn't quite make that connection that we're almost talking about individual batteries hooked up together to make one system.
Exactly, yeah. Each one of these is, between 4 and 5 watts it produces of power.
So that's our last string of the 60 cells that make the panel.
It'll pick these up and transfer them to the next station, which is where the actual electrical connections are made. Now what we're doing is we're taking all those individual cells that are joined together, and now we're connecting the negative and positive aspects of them.
And I see on that end of the bus bar, there's actually some leads coming off that, and that's what's going to get the power out of the overall panel.
Yes, correct. You'll see that as when at the stage where the junction box is placed on, that's where your connections are made, actually.
So these bus bars then are really taking these strings and making them into completing that circuit all the way around through the panel.
Exactly. It's making it one, we'll call it one power source. And then what happens here is it's up again for another inspection. A piece of glass is picked up and transferred over to be put down and brought into place. We have to do a lot of quality control inspections because, as you'll see in the process, once it gets to a certain stage of lamination, there's no correction in the process. So they place the EVA on, which is basically the encapsulant. Once they place that on top of the glass, what they'll do now is they're actually putting a identification barcode on it, so we know basically when every panel was made and where it was made, just for traceability, for again, goes back to the quality control. That finished string is now placed on the EVA in glass. It's then transferred to another inspection station. This is what we call a light table. What they're doing now is checking measurements. They're making sure that it's true and square on the glass, and that again, it meets our specifications for quality control and spacing.
You mentioned the glass that it was set down on and the EVA. That's really what we're looking at when we're looking at the front of a solar panel. We're kind of looking through that glass. Basically,
you're looking through the glass. The EVA that's placed on there, and there'll be another sheet put on, what happens is that melts into a clear. And it's basically what it does is it encapsulates the whole module to make it basically a weatherproof system.
Right, because it's got to be sitting out there in the weather, in the rain, and everything else that the interior weather is going to throw at them.
Exactly, and we guarantee these panels for 25 years. So they have to basically meet to those standards, or they'll never last, and especially environment in Ontario. It's the final sheet of EVA. Again, what we were talking about, the encapsulant. So this is going to complete that sandwich for the encapsulant. Now they'll take the final piece of the sandwich, if you want to call it, and that's the back sheet. They do a continuity test. So they test to make sure there's been no breaks or disruption of the soldered joints.
Make sure all the connections are good.
Correct. After all the electrical connections have been made, it's all been tested, the EVAs, the back sheets are on. Now it comes to the lamination process, which basically what they're doing now is they're covering it. It's almost like a Kevlar sheet. It's just to protect it for any melting. The process now, they'll be taken into the laminator. It'll go in there for approximately 18 minutes at about 160, 165 degrees Celsius under pressure and vacuum, which then melts the EVA and again creates that completed module. And the panels that are the finished product now come out the end of the laminator.
Wow, it's hot.
The cooling, they're 160 degrees Celsius right now. We have 6 cooling fans that you'll see now are going to start to cool. There's about a 10-minute process of cooling the panels down. Once they're down, the Kevlar sheets are peeled off and it'll be ready to go onto the light table for inspection. And that's basically the product now is finished in an aspect of, except for the junction box and framing, but it's protected. It could literally sit outside now because it's a finished product.
It's weather protected.
It's weather and it's completely sealed. And you'll actually see how the EVA has melted over the edges. Because after it comes out of the laminator, it comes to the light table where they are inspected to see if there's any cracks or deformities in the panel.
So really on this light table here, what we're looking for are the connections between the bus bars and the solders all the way through it.
Yes, exactly. Here, these are the laminates that we saw come out of the laminator. It's placed up on the trim table. He will then trim the excess EVA and back sheet off.
Okay.
Just doing now. He'll have that. And then basically this process is to ready it to fit inside the frame. We have our silicone station. What he does is puts a silicone sealant on the frame, and that again ensures that it works as 2 points. One as an adhesion, and secondly as a sealant to guarantee that the module is completely watertight. you'll notice that when you see the frame, there's actually a corner, what's called a corner key system on it. And this corner key is already pressed in. We press it into the one stage first, and then it'll be placed into the side rails. What they'll do is they're just positioning it now before it goes into the actual framing machine, which then takes pressure and secures the corner keys together.
Okay.
As they transfer it here now to the framing machine, they'll operate controls over here and they'll have it pressed together.
In the framing machine here now, then all that caulking, that sealant, it's all coming in to tie the whole thing together as one panel.
Correct. And then what you'll see is if you ever look at the back of the panel, you'll see some excess on the back. There's always a small amount of excess silicone on the front, and that's where that's part of the cleaning process.
And so this really forms the structural integrity of that unit when it goes then on a racking system, whether it be ground mounted or on a tracker?
Yeah, but actually the frame is more of a fastening point than anything. Now you'll see that they'll transfer the framed module over here. Yep. And what they're doing here again is they're just inspecting, making sure that the frame is completely pressed together. And
excess caulking.
Excess silicone is coming off. Again, this is just a cleaning process before it goes to the next stage. So now that they've done the cleaning and inspection of it, now is where we put the junction box on. They're doing some added protection with some silicone on both sides. Again, to guarantee a watertight seal. And the junction box has silicone on it also. What they'll do is place it in with a little bit of pressure. And now what we're doing is we're actually making the physical connection.
You got that one going?
The connection is basically your negative and positive connections.
Again, the panel's generating DC electricity. That's what's coming out here.
Yep.
The strings are connected back through the bars, through to these connectors, through a junction box, out to an inverter.
Exactly, and you can see it's very simple. You can see that there's a positive connection and a negative connection. Again, back to a simple battery.
Yep.
Same idea.
Al, we're in the flash room?
Correct. What happens here is that the panels are placed on what's called a simulator. So what it does is it simulates the sun. It'll flash, and then we will record it. That ensures that every panel is performing to what we claim it to be, as in if it's a 250 panel, that we know it performs at 250 or better.
Or better. And really that is part of the quality control, that it's going to do at least that or better.
Exactly. So if it's a 250, we guarantee that that panel flashes over the 250. And if it didn't flash at a 250, then we would sell the panel at a 245.
I understand. So we've seen the flash, and it generates some readings to be able to show that indeed it did that.
And we produce a printout. So every customer gets a full printout of all the panels, telling you the serial number, the temperature was flashed, all the parameters, and also the performance of every panel.
Well, this is the final product here as it's shipped and ready to go.
Yeah, it's all packaged up, as you can see, ready to go. It's inside here. It's also saran wrapped and strapped inside.
You know, it's been an impressive tour because we've gone through this process from the beginning of these small silicon pieces and assembled through the process, out to the panel, sealed into the unit, tested, all along through the process, and finally here now in a box ready to go to someone. It's been impressive.
Yeah, and you know, the great thing is that gives people, it seems to be a great mystery in Ontario about solar panels, and I constantly have people asking me, you know, how are they made? So, you know, this is a great opportunity to walk through with yourself and explain how it's made and showing what OSM's doing and how we're moving forward.
So that really is the process of turning the sun's energy into electricity. But you know, the common denominator between all those connections, again, whether it's roof mount, whether it's ground or tracker, is that they're all going to be connected up and pump that energy back into the grid.
That's correct, and people will benefit from the feed-in tariff payback, but also in the long run, it's gonna help the infrastructure of hydro in Ontario.
You know, it's about creating green energy, it's about creating green jobs, and about creating revenue and opportunity for people.
Exactly. We're proud at OSM to contribute to the new jobs and the new manufacturing in Ontario.
Very good, Al.
Thank you very much.
Thank you.